In this video, we are going to look at how to balance redox equations in acidic solution using ion-electron method. So I will only cover one learning objective in this video, which is write and balance redox equation by ion-electron method. To balance the redox equations in acidic solution using ion-electron method, we just need to follow through 5 steps. So the first steps will be balancing atoms beside hydrogen and oxygen atom first. Then only we balance oxygen atom using water, and in step 3 we balance the hydrogen atom using hydrogen ion. Then in step 4 we balance the charge using electron, and in step 5 we multiply each half equation with an appropriate integer to equate the number of electrons. Now I'm going to move on to use example to explain how to balance a redox equation using ion-electron method. Before we start balancing, we must divide a redox equations into oxidation pair and also reduction pair first. So how do we do that? We shall look at example 1. In example 1, we have the permanganate ion react with oxalate ion to give manganese 2+ ion and also carbon dioxide. So from this example, can you see that the permanganate ion consists of manganese atom and also manganese 2+ ion consists of manganese. So obviously these two are a pair. And then for the oxalate ion consists of carbon and also carbon dioxide consists of carbon. So in other words, oxalate ion and also carbon dioxide will be a pair. So before we start balancing, we just need to divide a redox equation into oxidation pair and also reduction pair first. After we have separated the redox equations into 2 parts, now we can balance each part using the 5 steps. So step number 1, we balance atoms other than hydrogen and oxygen. So in the first half equation, the other atom here is the manganese atom. So in permanganate ion, we have 1 manganese atom, and on the product side, we also have 1 manganese atom. So means that the manganese atom is balanced. Then now we can move on to step number 2. Balance the oxygen using water. In permanganate ion, there are 4 oxygen atoms. On the product side, there is no oxygen. So how to balance oxygen? We use water. So in permanganate ion, there are 4 oxygen. So means that we need to add 4 water in order to balance the oxygen. After we have balanced the oxygen, then we need to balance hydrogen using the hydrogen ion by adding water to balance oxygen. In step 2, we add in 8 hydrogen atoms. So how do we balance the hydrogen atom? We need to use hydrogen ion and we need to add 8 of them on the reactant side. After we have balanced the hydrogen, then we can move on to balance the charge using electrons. So how to balance the charge? First, we must find total charge on reactants and product side. So how to find the total charge? So basically, we just need to multiply the coefficient with the charge. The coefficient with the charge. Okay? So, and then sum the total charge. So how? So on the reactant side, for hydrogen ion, there are 8 of it, and the charge is +1. So we just need to multiply this coefficient with the charge. And then we sum it with the coefficient and the charge for the permanganate ion. And then what we get is +7, and that is the total charge on the reactant side. And we do the same thing for the product. So for manganese 2 plus ion, the coefficient is 1 and the charge is +2. And for the water, coefficient is 4 and the charge is 0. When we sum them together, we get +2 as the total charge. So can you see that on our reactant side, the total charge is +7, and on the product side is +2, and the difference between them is 5. Okay, the difference between them is 5, so means that we need to add in 5 electrons. And the electron, because the charge is negative, we need to add electron on the more positive side. So our more positive side here is reactant. So we need to add electron on the reactant side. How many? 5. Because the difference between the charge on reactants and the product side is actually 5. Before we move on with step 5, we must repeat step 1, 2, step 4 for another half equation. Then only we do step number 5. Okay, so now another half equation. Again, we need to balance atoms other than hydrogen and oxygen first. And for this half equation, the other atom is the carbon. So on the oxalate ion, there are 2 carbon atoms. On the product side, carbon dioxide, we only have 1. So how to make it 2? So multiply by 2. And then we need to move on to balance the oxygen. So is the oxygen balanced? So on the reactant side, oxalate ion, there are 4 oxygen atoms. And on the product side, carbon dioxide gas is also having 4 oxygen atoms. So oxygen is balanced. Then we move on to step number 3. Any hydrogen present? No. So means that we don't need to do step number 3 because there is no hydrogen presence. Then we can move on to step number 4, how to balance the charge using electron. So again, we do the same thing. Now oxalate, on your reactant side, oxalate ion, there's only 1, but the charge is -2. So what you need to do is 1 times -2 to give you the total charge on the reactant as -2. And how about the product? So on the product side, we have 2 carbon dioxide multiplied by 0 because the charge of carbon dioxide here, there's no charge, right? So means that the charge is 0. So 2 times 0 equals to 0. So now the difference between the charge on the reactant and also the product is 2. Okay, it's 2. And must remember, electron, we need to add in 2. Okay, because the difference between the charge on reactant and the product side is 2, so we need to add in 2 electrons, but on which side? Again, must be added on the side which is more positive, and here is our product, so means that we need to add in 2 electrons on the product side. In step 5, we multiply each of the half reaction with an appropriate integer to equate the number of electrons. So for the reductions half equation, the number of electrons is 5 and the oxidations half equations, the number of electrons is 2. To equate the number of electrons, the reductions half equations we need to multiply by 2 and the oxidations half equations we multiply by 5. And then we sum both the reductions and oxidations half equations together to give our overall redox equations in acidic solutions. When we sum both the half equations, reductions and oxidations half equations together, you can see that the 10 moles of electrons appear on both on the reactants and also the product side. So this means that we can cancel out the 10 moles of electrons both on the reactants and also the product side. And this is the overall redox equations in acidic solutions. You may want to pause this video for a while to try on test yourself 1. For further reading, you might want to refer to the Brown's book, page 896 to 900.